All right, let's talk about water cycle. So water is a weird chemical as far as we look at different properties of things. It's on our planet as a gas and a solid and a liquid, which is kind of different. Most elements aren't like that on our planet. When it's pure water, it is not a conductor. It doesn't conduct electricity. It's a really great solvent, which means lots of stuff will dissolve in it. It's pretty stable. It's not reactive. It's a great medium for other reactions to happen in. And it's really important because it's a main ingredient for photosynthesis to happen. So, chemically, water is polar, which means it has a positive end and a negative end. So it's sticky, so it likes to combine with other things. And the pH, its acidity, is very neutral. It's right in the middle. So remember, acids are low and bases are high, and water's right in the middle with 7, so it's neutral. So it makes it really versatile as far as chemistry goes. So we need water to live, right? So it's sticky. That's what the cohesion stuff is, and the adhesion. It helps to regulate temperature, so not too hot, not too cold. It helps to kind of keep our temperatures even. It helps to dissolve different substances, so if something does get into our environment, it helps to kind of get rid of it. So it's kind of a natural, um, I guess, buffer for harmful stuff, for harmful chemicals. And when it is solid, it floats. Ice actually floats on top of water, which is weird because usually solid substances sink under their liquid selves. So that's a weird property of water. So why is water important? Well, we got to drink it, right? But we need it for the very most important thing, to make food. Remember, we can't make food. The plants have to do it for us, and they cannot make this glucose food without water reacting for it. So for all the cells to do their jobs, their functions, and for us to break apart this glucose and make ATP and have energy, we need water to help us do all of that. So we're very, very dependent on it. Water is really important with a lot of stuff environmentally as well. So remember that climate is dependent on two things, temperature and precipitation. And so how high or how low you are, your elevations, where you are on the planet, what bodies of water are near you or are not near you, how the air moves, how the ocean moves, all have to do with water. And where this water is or is not will affect our climate and can change our climate. So the amount of rainfall, how moist is your soil, what can you grow, what can you not grow, how much runoff is happening, how much water will go into your soil or run through your soil, clay or sand, and how much water gets evaporated due to the heat to go back into our atmosphere. So water is a really, really big deal. It's also, which is weird, most kids don't realize, it's a greenhouse gas. So what is a greenhouse gas? It is a gas that can warm our planet. So it will magnify in some degree the heat of the sun coming to our planet. So if this is the Earth's surface and we have this atmosphere floating above it, when the sun shines and sends down its rays, here's the sun, it sends down its heat, it'll bounce off the Earth and escape back into space. However, if there are certain gases in our atmosphere, CO2, nitrogen oxides, methane, and water, these molecules will do something weird to the sun rays. And what happens is the sun rays will come in, but they'll try to leave and bounce off these molecules so the sunlight will stay in and it won't escape. So instead of letting the heat escape, the greenhouse gases trap the heat, and so that's why we get a warmer planet, or that greenhouse effect or the climate change or global warming or whatever we're trying to call it this week. So, interestingly, look at the kind of wheel of greenhouse effect gases. So you can see the big boy here is N2O, which is from combustion of cars, carbon dioxide, which is also from combustion and respiration, and then ozone, which is also from cars and combustion and smog and some other chemistry, and then methane, which can be from the cows and some other stuff too. And oh, sorry, I totally did that wrong. This color is not N2O, it's water. It's water vapor, which was the point of our talk. This is the N2O. Apologies. So here's the weird thing with water. We need water in our atmosphere. It's good. But it's also a greenhouse gas. But it's a natural greenhouse gas. So as long as it's there in balance, like it's totally fine. And the effective greenhouse gasness of it is pretty low. So it's not a strong greenhouse gas. So if we give values to the greenhouse gases, like carbon dioxide is usually given a value of 1, water is like given a value of like 0.2. Whereas like methane is given a value of like 30. So some greenhouse gases are way more stronger or ability to trap the heat a lot more than other greenhouse gases. So yes, water is a greenhouse gas, but we don't worry about it because it's natural and we need it in the atmosphere to make our weather and our climate and everything work within the water cycle. Okay, so these are the main greenhouse gases. I don't remember what these are if I click on them. It's been a long time. Oh, it just tells you about them. Okay, we don't need that. Eek. Okay, come back. A list you should know, just to know which greenhouse gases are there. A lot of times you'll see a multiple choice question. All of the following are greenhouse gases except for, and pick one that's not there. So water, even though it seems like pretty soft and liquidy, is pretty strong. Look at all the landscapes that water can cause. The Grand Canyon, these river oxbow curves, these weird swirls in the sandstone. The waterfalls are taking away the rock. It's carving away the seaside. So water over time erodes rock and it freezes and it cracks the rock and it can reshape the surface of our planet over time. So water shapes the earth. Water is also really cool because it purifies things. It'll go underground, the water will percolate in through this bedrock, and the water moves really slow once it's in this bedrock, and it purifies and cleans and takes out the bacteria and other harmful things, and it puts out fresh water, fresh water. So, what do humans do to wreck it? Well, we use too much of it. So we're pulling out more than we put in. We are putting more stuff like fertilizers and pollutants into the waterways, and it's running off and getting into our streams and our lakes and our oceans. We're putting down roads, so the roads are preventing it from going into the soil and not getting that free purification because of roads. We get more flooding because we're covering up our soil, and so water just accumulates. We cover our soil, and so we don't get that percolation going into the soil. And we're deforesting, so transpiration's not happening, clouds aren't forming. We're actually changing the weather cycle, the water cycle, sorry, because of our practices. We're having less shade, so because there's less shade from less trees, the water's evaporating faster than it can get into the soil, drying out our lands and causing a little condition called desertification. Desertification. So our soils are becoming drier and looser and more susceptible to erosion. All right, so you should be able to put that in your AP Comp book and make an awesome water cycle drawing off of that. And that's your water cycle.